Hello, welcome back. So what we're gonna do today, we gonna play a bit more with Pix2Pix. So the model that allow to do something like this, and the one I did this live show. So this is machine generated visuals. I use Pix2Pix model. This video is gonna be part of this post. So here you will be able to see a little bit more information about training, about experiments, result, and yeah, you will have this video at the end. So first of all, what's Pix2Pix is Pix2Pix. So Pix2Pix basically allow you to transfer one image into another. So here is the example. Do sketch and after it generate. This is I think cat's example. Yeah, down at Twitter, what you draw it will try to generate cat, some other weird stuff. You can use Pix to generate kind of map based on the satellite image, or generate visuals based on the segmentation map. Yeah, for example, on colors, you draw something. So this and this example, you just draw element and it's okay. Blue one is like top of the window, some decoration. This blue, the wall. Yeah, in English not much. I don't know, at least I don't know much words for blue. Super light blue and blue, right? In Russian you can call it different words. To generate black and white color, to colorful, day to night, night to day, I don't know, yeah, image, this is pretty much the same. I did for the faces, and it's kind of a lot of different things you can do. A little bit more you can find here in ML4A. So it's talking a bit more about theory behind. Its theory, it's pretty simple. Model by themselves not super complex also, but it can have like quite different result. Yeah, like dips map to the image. Okay, internet not so fast. Or if you do like this dips maps, it also kind of still try to generate city, like old faces. Another one. It's kind of a lot of stuff, and I think it's this Pix2Pix you can do a lot of fun stuff. So we will start today from the implementation, how to connect it with TD, get output, get input. It's still the same pretty much what we did before. We will use this repo, or you can use to the original one. I don't think I did much changes, and it's more changes in my repo here. It's just for myself, I think. Some small additional stuff. And why did I close it? Good question. Okay. So first thing first, let's get it done. Okay, desktop, I will create folder Pix2Pix first. Terminal, cd, let's go to this folder. And first let's clone this repo. Or you can just download zip and download the archive. Or if you use Git for window, like for desktop, you can use open desktop. Last few days, Git for desktop started to work for me. I don't know why. It's very weird. And not so convenient also, to be honest. Okay, I don't need. We go inside. In terminal, if you don't know, when you press tab, it will like finish the word if it has some. And if you type it right, dir for window, ls for Linux. So we have this file and we have requirements file. This tell what we should to do. It's use torch 0.4. So we will go with the Python 3.6. So again, I use Anaconda. I will create conda, create n Pix2Pix Python 3.6. It will give me error. Like this should be. Yeah, install. And activate Pix2Pix. Okay, now you see here, it's activated. And what I'm gonna do, I need to install PyTorch. You see here we need the PyTorch 4.1. Okay, let's go here and we will use this one. Copy, paste here. And what I will need, this I will disable, it will define by default. In PyTorch I need 4.1. Okay, let's check here. PyTorch 0.1 with CUDA. It will install CUDA. It will install CUDA toolkit. So everything. That's why I like Conda. I don't need to mess around by installing CUDA in the. I still have CUDA in the Windows environment for compiling for C stuff and like other stuff. But yeah, with this one it's much more easier for Python. especially again I can have different version on one machine. But this time I see my conda directory getting more heavy and heavy, but it's still far away from Unreal Engine. If you really work with it deeply, it will require like 20, 40 plus gigabyte, right? Okay, while this is installing, let's go here and looks how it's work. Okay, test. Have mine, test page, number trade, batch size, serial batches. No, so just code. This is set up. This is directory where it should save. Creating directory, evaluate. This we don't need. So pretty much this is all what it's doing. This is all code pretty much for model. Most of this stuff we even do not need. Let's keep installing. By the way, let's go and do one more things. We'll need like our spot library. Open. Okay, I need just a library. Yeah, from this I need just library and template. I move here. And first things first, in library let's go and we use 3.6 Python now, so this one 3.7, so we will need to use this one. I will rename. I think I will update the spot library soon to make it a little bit more simple to use also. I don't know, for me it's quite simple now already. And here, okay, our template, it's ready, we have library. And we see now, let's set up, okay, my models was trained by 512 to 512, so we will use this one. Type in input output, spot size, spot input name, input output, and silent, let's set up true for now. And here the things happened, yeah. Again, basically what we need to do, we need just put our code here in line 33 inside. And by the way, yeah, let's create some directory here. We already have models directory. Okay, I will call it result. Go here and I will put some models here. Pix2Pix, PyTorch. Okay, let's do one of this. I need to name it. Okay, Safari. .512, and basically I need just copy this one. I will also share a link. I will upload few models for you to test. It's still installing, and Yeah, first things what I'm gonna do, I'm gonna copy test. I will call it test2. So on this one I will first check out the model, and here I will need to we go here. We see we need to put some options to run it. And to make it easy, I usually create bat file, and I just put here paste data root name results. Let's rename this model to make it easier. Why? Because you see here, so it will save result, but it will get model from this same folder. Results map cycle gun. So here I need to change to the name C5512, right? Sif, and model name the same. No, model here it should be Pix2Pix. Sickle gun, yeah, here Pix2Pix. Test P data root name model Pix2Pix. And direction, in my case it's A to B. So if you will see here, yeah, A to B. And also you see here I will need save it. This is another one. So data root is where gonna be my data. Data sets, and I will call CFI here, and I will need to go again to the, this is still installing models, data, Pix2Pix, Safari, to a second one, so it should be something like this. So we can just pick up some images from here. This is what I was training on. And I think it should be test. To check it out, we can go again, datasets, CFI, right? CF again. Let's save it. It's still running. Okay. Option test option parse. Test option is go from options test option. So we go to options. Let's see base option. So data root. So that's how you can find what's the option we need to do. Patch to images. Should have folder trend A, trend B, val A, val B, etc. Name, GPU ID, if you wanted to define checkpoint directory, model, input, this is we don't need. By default it will pick up the one we copy with name latest one. Number layer, normalize, not drop. So most of the model here for training. So A to B, number traits, max dataset, epoch. Okay, and for test option, let's see, and test. Number of test example, result dir, aspect ratio, by default one, face, default test, evaluation if you want, and okay. So this is pretty much. We'll still wait a little bit. It's work. Let's take time. And while we're waiting it, let's just create some touch file, prepare something for training. Touch designer, too much different versions. Okay, what we will need to do, we will need to have our audio file in, for example, or audio device in, depends what you want to do. Switch, one works. Yeah, it's mono now. Okay, and basically here what I can do, I will just select one channel, and it's have a lot of frequencies. That's what I brought here. Again, yeah, I did different experiments. So first one, okay. Yeah, who curious, also I start to publish video for processing for my course in university here that I'm teaching. So you see that's like different models I have. Just different way to prepare information. Come on, internet. So this is first one. You see it's a little bit too much. Yeah, it's always change image because okay, it does not take in consideration the previous frame, previous time, and you don't really can see much. Wait a moment. Oh, I don't know why my resolution just changed. So you even cannot see the on the bit or other stuff because here it's current time frame, right? 735 channels. So it's pretty much every frame is changed totally. So here I added a little bit more. So this you see much more smooth, a little bit more, because here I get kind of like average for last 10 seconds. So now it's taking consideration what the previous frame was, and so and so and so. This one I use the audio analysis, low, middle, high, key expert, yeah, like all these references. But because this frame, it's time dependent also, it's calculated from like last, I don't know, some number of frames, and this one. It's by default already have some taking consideration the previous frame, yeah, it's not jumping too much. And here you can see more like because like kick and snare is more affected. And here the same, but again here the same, but again I just put it like for last 10 seconds, so make it more smooth. So last one pretty ambient, but for example I can combine previous model and this model, just maybe add here some circle or background color a little bit based on the kick. So if I wanna a bit this model more reacted to the some like events, yeah, like kick, drum, or some like really momentary events happened. Okay, at the same time our model here finished, and we can try to be inside. I can run but okay, dominate. I did not install pip install dominate. So you see now error, it cannot find the model, so model should be in the folder checkpoints, not results. I go here, but I already have folder checkpoints. Yeah, from results I just get this out, put in checkpoints. Run again, load it. Okay, to image by default, yeah, I think it is limitation for to image. It should be in results, images. Okay, so here you see this is prediction, input, output, prediction, input, output. And one moment more, let me check. Oh, this should be 124. I think the model I used why it's here, it's 215. Let's first change here to test 2. I think I used the wrong model. Let's just here. Log works the same. Test options, base option. Yeah, I think this one I need defined load size and crop size. By default it's 256. So now it's also cropping the image I have 512, crop size 512. Sci-fi test images. Okay, yeah, now you see it's like closer. This is original image, this is generated from this input. Now you see it's closer because before it's cropped just like some part from it. Yeah, so this is nice. Again, it could be trained for much longer and more images, so to get better output. Basically, most of these models was trained just during one night. Okay, now this part works. Now next things I need to clean it up a little bit. What we need, what we don't need. Okay, get test option, number thread, batch size, batches, no flip, display d-1, dataset, create dataset, model, create model, model setup, web directory. This I don't need, I don't want to save it. In file, web page. I don't gonna eval in any case, so this can I delete. For data in data enumerate data sets. Web page save. I don't want to save it. This I don't want to print. Image path, visuals. So visuals it should be image. So let's do this one first. This I can delete. And I don't think I need this option, create dataset, create model, save images. This one I don't think I need. Okay, let's try run it. Double check it. Test 2. Okay, you see it works. It done not saving now. It's give me tensor, real B, real E, CUDA, device. Okay, works nice. I comment this part. This I see it works after I clean up it. Next, what I need to do, I need to figure out what this data format, right? Because this way I will need to fake print data and print data shape. So I need to figure out what's the format here and what it's inside. And here just set up let's to 1. I don't want to go through the whole image. Speed up process a bit. Okay, it's dictionary, it's have not attribute shape, right? But that's what data have. A path, B path, tensor, A tensor, B tensor. Pretty much in here from -1 to 1, I think the format go. You see here -1 to 1. So data, I can define I want a and data a shape. Okay, so here is the format. 1, 3, 5, 12, 5, 12. It's the shape of tensor, and here is data, right? And one more thing, so let's do print min data max data. Not data, data a. That's what interesting for me. I'm not sure it will work for tensor now. It should work for numpy arrays. Yeah, it works from -1 to 1. Yeah, so all our input image we will need to convert to this one. Good. So next things to do. Let's clean up everything now. So now I will need to use my template siphon. Okay, it's here. I'm not gonna parse configuration here because it have its own parser. I don't wanna conflicts. So I will copy this function. That's function where we're gonna do everything. And in main, I will need to basically just copy all this stuff. After we load model, I will set up siphon with 512, 512. This one I can delete. Required type input output. Receiver name input, server name output, silent true. Okay, pin, DDD, project, cloud density. Okay, this part. After we need to put this part. And basically now we need just copy all this stuff that rest here. And this one I will just call the main function. And this main function I will call it from here. Yeah, so okay, should be fine. What now? Just we need our we did not copy everything. We need to output. Yeah, so now we need to go no, I already copied it. So this part I will need to put into our function. Let's try. It will give some error now. Okay, first of pgame for spot pip install pgame, pip install popengl. It will ask also open gl. And let's just do simple way. I can just do this for now. Just make something like this. And we will siphon out with name input. And we need siphon in with name output. Put it to null. And let's run. Model loaded. Okay, dataset is not defined. It's right because here inside my PPLA I need dataset and model. I need put model and dataset because it is outside of my function, so I need to send it here. Dataset we not really will need after, I think, but model we will need. So now I just want it's work. We see it's a bit slow because it's also need to print it each frame. Let's close it. Okay, good. So next step, now we need to figure out this part. First of all, let's convert it. Convert. I need convert these visuals to the so let's again print data first. Not data we need. Let's start from output. Okay, it works, and we see we have real A, fake B, and real A. So what we need fake B here, So I can write something like output equals visuals tab doesn't work here, fake B, right? But and let's print output here. I will run it. It will give me error now because it will not be able to send this image to Spot, I think. Because it's on GPU now and it's tensor, it's not array. I need convert to the array. So to do it, I need to use data. It's for PyTorch function to CPU. I need copy the information to CPU, and I need to transfer tensor to NumPy. Save. Let's run. Okay, it's work, but you see here it's the input it give me, it's pretty messy, right? because why? Let's check it, because it's format output shape. Yeah, you see this format now, 1 3 5 12 5 12. And if I will print data shape, so this is our spot in signal, you will see difference because it will expect something similar. So we need to have something 5 12 5 12 3 to output, not 1 3 5 12 5 12. Right, so for this we also can. So first I need just get rid out of this dimension because it's batch size, and I need to reorder this. It's kind of not hard to do. I can use like output equals, I will use numpy transpose output, and the format gonna be 0, it's gonna be the first one, 2 3 and 1. So it will be 0, and after it will be 5 12 5 12, and after it's gonna be 3. So it's gonna be pretty similar, but it still have one more dimension, so I just use the sample 0 from this dimension. And now let's run it, and you will see now we will have the totally the same format. Yeah, it's better, but it's still, yeah, weird looking, because also why? Let's print data here, let's print output here to see what's the difference, because again this is most part of the work. So you see the input data here, it's gonna be from 0 to 255, I think, because also it depends, yeah, the texture assigned by, it's gonna be from 0 to 255, but output we have here, it's from -1 to 1. We can try. I actually did not try yet this operator much here. Maybe it will work, because here I need to set up it should be from -1 to 1, and from 0 to 255. No, okay, it does not work because I think it's gonna clump value. Okay, so we just convert it here. This is pretty much most of the work. Also, when you work with, need to convert, you want to use some like machine learning model, you need just to figure out how to get the same data, right? So output is going to be as we have from -1 to 1. I will gonna do output +1. So now it's from 0 to 2. Yeah, we just move it a little bit 1, and I can multiply it by 255 and divide by 2, because it's now gonna be from 0 to 2, -1 to 1, 0 to 2, 0 to 5 10, and divide by 2, so from 0 to 255. Let's try. Okay, now you see, yeah, it's but this is input from image. It's not yet reacted to this one, because this is second part. We need to get our input here in, and I don't need this for data in datasets. Okay, this we can kill. So now again, let's go back here. And let's to see what kind of data we get here. We defined already as our model from A to B. I need to work with A, yeah, again. So I need to have my data in the format -1 to 1. It should be tensor, and it should be this size, but this is part of the data. So what I'm gonna do here, I need to do pretty much like opposite from here. This I don't need. So before the data, what I will do, first let's transform it. Data equals data divided by 255 0 to be sure it float, multiplied by 2 and -1. So we go opposite from 0 to 255 to 0 to 1, 0 to 2, and altogether -1 to 1, right? Okay, now I need to change order again. You remember the order we have 512, 512, 3. Now I need to change to this one. The same data np transpose data. We set up 2. First one is this 3 gonna be first one. 2 0 1. Good. And now I can convert it to the sensor. Okay, let's do shape here, because also you remember I need to add one more direction here. I can use squeeze and squeeze, or I can do just something like this. Just put it one more dimension here. It's a simple trick. Now it's list. Okay. Yeah, let's not do it this way. So yeah, now you see like 3 to 12, 12, 12. Okay, good work. And next things to do, I just use data torch. Let's call it equals torch tensor. So we convert it to the tensor. And it's data here, yeah. And here I will add one more dimension because it will convert it. And now if I do like this, and I add shape here, name torch is not defined. Okay, I just need to import torch here. Because we use in the other function, yeah, but not in the same script. Okay, that's what we need now. Our data now from -1 to 1. And we have torch tensor, yeah, with this size. And all I need to do now, here, I need just write, because this data we have from dataset, I can just write, I will call data, a, that what we use here, equals our data torch. So I just replace it, yeah. I still load the image now, but because I need to use the format and you remember when we print like data, we have like much more stuff here, yeah. So I still use it, but what I need now just is replace data a, that all what important for me now. And let's run it. So now you see, now it's generated. It's a bit slow because I print too much stuff here. Now, okay, it works. Now we just need to optimize it. I don't need this part. And so this data set, I think I can just replace. I don't need this part. And I don't really need this part because I don't need this loop because I have just one value now inside. So data equals data set 0, run. Okay, it does not work this way. So what I should to do? I can just replace this one. I think what I will do, I will use here just dataset. And here, when I load it, I will use this what we used before at the beginning. Here we have so after I load everything, I go from data, if more than one break, it's just trick, and def data will be data. Good. And now all I need to do in my function, I need just send def data. And I also not need to load this picture every frame. And you see it's pretty much faster now. It's 512 resolution. We're receiving, not bad. So it's work. Why also I do like PyTorch in this case. I can run multiple models. For performance I did, it was like 4 models running simultaneously. And you see it does not eat so much CPU, GPU. So Python part pretty much done. I think all what we need to make here, yeah. So what we create just like the bat file, so I can just create now multiple bat files to load different models. We figure out where we can check the options for this model, right? Because yeah, we see just options, test options, options, test options. We clean up a little bit original code to get rid of what we don't need, like saving image to the file, loading file from them. We still load one image, so we still need keep one of the image in the our dataset folder, or we need just generate empty tensor with like the same format as it's generate when it's load image here. with like A, B, and like, but it have some other stuff. So I think it's easier we just like load one image and after we just replace the part we need with our information. Small trick. Spot part, we did not do anything, we did not change anything, pretty much just we get rid of the parameters of spot and I set up just here. And now, okay, this model was used a little bit different format, right? Yes, so something like this. And how I did it before, after this select, I don't need to use usually select here. I use trail after. So now you see it's like this. Yeah, let's get sound. After use resample. To 60 samples. I can make it more. I can go for till it's 512, yeah. To be quite precise, of 512. And after I just can use to select channel 1, channel 2, and I can use chop to SOP, simple, and just channel 1, it's gonna be P1, channel 2 gonna be P1. I can transform it a little bit, make it go up, merge, transform it a bit more, geometry, camera, just constant texture, render, $512 in this case. This I can move here and just adjust the position of camera, right, to put it in the center, kind of put it closer. And this render I can put here. So this is pretty much output of the model, yeah, should be what I have now. Audio device out. A famous song. And one more thing I can do here, I can just put some math here to adjust this line, yeah, a little bit, maybe not so. Make it a little bit. So you see also like it depends what kind of image. So now I can control my basically visuals generated from the sound directly, but I also can tweak the parameters of the sound to affect the visuals I know even if I will change color, it will change the visual. Let's just for camera setup black background. Even it is black, it still do something because it still have some channel, yeah, other channels. So now we have kind of a lot of different variations to play with it. And this is, yeah, pretty much everything for today. A little bit short, quick about training. If I go to the let's change to microphone. Ha ha ha. Why? So yeah, microphone, it does not affect so much, I think. The signal, I think it's very low from microphone. So to get some signal from microphone, I need maybe something like this. Yeah. Yeah, about training. So you see, this is was set up for play, different models. So I have just different components which will generate different visuals. Here I use switch. And here I have video file and sound related to this video file. So I download just like over 1 hour video from YouTube, different like from games, from like sci-fi movies, trailers. And what will I do? I just like layout them together and I save it. And I just set up different FPS or like simple Python script that will trigger the saving of image. I can also speed up speed here after. And I get my training datasets. That looks like pretty much something like this, yeah. Different one. You can see it's not so much, even like around 1000 pictures here I have. So, but when you train your model, you need to have train and I think you eval. This is also just need to check documentation. Go to the tips, how to train model. You see, you can use rectangular images, you can use different size with crop, with no crop. Yeah, val. So this should be val or test. And usually I just like pick up like 5%, like, okay, if I have 1000 pictures here, maybe 50 from here, and move to this folder. And yeah, you can go after here, PyTorch collab, Pix2Pix, open it. And you follow your clonate, import. This part you don't need because you don't have this data set. Basically, after you need just change this to folder where you dataset looking for this. Usually I put it in my Google Drive and connect it here to Google Drive and train it. And that's all, not so complex, just a little bit experimentation. It's easy to get with. Okay, this one I close. This one I can close. This one I will save to I already saved somewhere it, yeah. And this one, yeah, we saved already. Yeah, so that's all. See you next time. See for the links for the GitHub and for the dataset we use here. I will upload to the drive. I will also put links there. Bye.